Welcome to the Deep Dive. Today we're on a mission, a really data-driven one. We want to identify which group of people alive today has the deepest, most long-lasting northern genetics.
Exactly. And we're not just talking about who lives furthest north now. It's about finding the genetic echo of millennia spent in high-latitude isolation.
Right, so not just geography.
Yeah.
You actually built a tool for this.
We did. We developed something called the Northern Genetics Index, the NGI. It's basically a way to quantitatively score different groups. Think Scottish Highlanders, the Sasami, Nenets, various Inuit groups based on specific genetic and historical factors.
Okay, but before we even get into the scoring, you had a pretty important rule, right, about population size?
Yes, crucial. We set a threshold, a minimum of 50,000 people. This was to focus on, let's say, sizable populations, not tiny, isolated family groups.
And that ruled out some surprising candidates, like Iceland. They seem pretty northern and isolated.
They seem like an obvious choice, but they didn't make the initial cut. It's about the timeline. Icelanders, while northern, mostly descend from Norse and Celtic people who arrived, relatively speaking, quite recently, maybe 1,000 years or so.
So it's not the millennia of deep, deep separation from major gene pools we're looking for.
Precisely. The NGI prioritizes that time depth. So Iceland, despite its location and, famous sagas, represents more of a historical transplant in this specific genetic context.
Got it. Okay, so let's unpack the NGI itself. What are the key ingredients? You mentioned 4 pillars.
Right. Pillar 1, latitude. Simple enough, how far north. Pillar 2, geographic isolation, mountains, ice sheets, that kind of thing.
Okay.
Pillar 3, and this one was weighted really heavily. The Southern Connectivity Penalty. This is basically a negative score for how easily a group could historically interact with large populations to the south.
So more connection south means a bigger penalty.
A much bigger penalty. Think of it as measuring the historical leakiness of their isolation. Was there a major land border?
Yeah.
Easy sea access to a continent? That incurs a massive penalty. And finally, Pillar 4. Population size and recent admixture, basically, how much recent gene flow from outside groups has occurred.
That Southern Connectivity Penalty sounds like the real game changer.
It absolutely is. It differentiates between just being remote and being truly genetically separated over long periods due to the nature of that southern boundary.
Okay, let's apply it. Who scored surprisingly low? You mentioned the Scottish Highlanders.
Yeah, they came in really low. NGI score of just 16.
16, despite the Highlands. Why?
Southern Connectivity Penalty, big time. That land border with England, plus relatively easy sea access via the North Sea, meant a constant, high-impact connection to a huge, diverse European gene pool just to their south.
So, genetically speaking, they're more like a northern fringe of Europe than a truly isolated northern group.
Fundamentally, yes. That penalty just overwhelmed any points they got for latitude or local geography.
All right, let's swing to the other extreme. The Greenlandic Inuit. They must have scored high on isolation, protected by that massive ice sheet.
Oh, absolutely. Near-perfect scores for latitude and isolation, really textbook geographic separation. Their NGI score was much higher, 65, but still not the top.
65 is good, but not number one. So what held them back? If isolation was great, it must be the other factors.
It was the admixture component. Their deep history shows incredible isolation, but more recently, things have changed. Genetic studies show the average Greenlander today has around 25% recent Danish ancestry.
Wow, 25%. That's a huge shift relatively quickly.
It is, genetically speaking. It represents a very significant, fairly rapid influx of genetics from a temperate European population, and that really pulled their NGI score down. It eroded that long-term isolation signal.
Okay, so the winner needed that extreme isolation plus minimal recent mixing.
Exactly. Which leads us to the clear winner, the Canadian Inuit of Nunavut. They scored an incredible 92 on the NGI.
92. So they combined the high latitude, the isolation.
Yes, all of that, similar to the Greenlandic Inuit in terms of geography, but crucially, they scored very well on the admixture component, much lower recent external gene flow. And importantly, look at their Southern Connectivity Penalty.
How did he do there?
Minimal penalty, only -5 points.
Just 5 points. Why so low compared to, say, the Scots or even Eurasian Arctic groups like the Sami or Nenets?
It's the nature of what lies south. For the Canadian Inuit, South isn't a densely populated continent with easy access routes. It's the vast, incredibly sparsely populated Canadian Shield and Boreal Forest.
Ah, so it's like a massive buffer zone.
Precisely. It acts as a low-density filter, historically inhabited mainly by other indigenous groups who are also somewhat related and sparsely distributed. It wasn't a superhighway for gene flow from large temperate populations like you see in Eurasia.
So that tiny penalty, combined with the low recent admixture, pushed them way ahead.
It secured their top spot definitively. They represent the best preserved example of long-term, high-latitude genetic isolation among sizable contemporary populations, according to this index.
So when we boil it all down, what's the big insight here?
It really shows that the kind of isolation matters more than just distance or how cold it is. Specifically, the demographic landscape to the south, was it a barrier or a bridge? And the integrity against recent mixing are, well, arguably more critical than just latitude itself.
It's a fascinating snapshot of deep human history etched in genetics.
But it's a snapshot that might be, fading. The very things that created this isolation, the extreme climate, the sea ice are changing rapidly, globalization connects everyone, and climate change is literally opening up Arctic passages.
Which leaves a pretty big question for you, the listener, doesn't it? We've identified this unique point of human genetic history, a result of profound isolation. What does understanding this specific moment, just before these last barriers potentially dissolve due to global changes, tell us about the future trajectory of human genetic diversity worldwide? Something to think about.